is Nernst equation? Give its application. It is a very important question in electrochemistry. Why we need to use Nernst equation after knowing electrode potential? As you know, electrode potential is a potential difference between an electrode and its salt solution. It can be oxidation, it will be reduction also. It is calculated in order to find how much current flows in external circuit. There has to be a potential difference. One rod should have more potential, other electrode should have less potential. Rod is called electrode in electrochemical cell. So I have to tell you about what is an electrochemical cell. इलेक्ट्रो एंड केमिकल स्प्लिट मीनिंग देखिए, ऐसा सेल जिससे इलेक्ट्रिसिटी का प्रोडक्शन होता है उसको आप क्या कहते हैं? इलेक्ट्रोकेमिकल सेल. ए सेल, ए डिवाइस which produce electricity as a result of chemical reaction is called electrochemical cell, which is such as dry cell, galvanic cell, Daniell cell, all work on same principle. We are using commonly in our laboratories for the purpose of producing current from chemical reaction. Let us come why we need to have the Nernst equation. Nernst equation is to calculate E naught cell. What is E naught cell? E naught cell आप किसे कहते हैं? E cell हम सबने पढ़ा है. E cell is actually a potential difference which allow the flow of current from one electrode to other electrode. When it is determined under standard condition, that means 298 Kelvin and 1 bar pressure, then it is represented as E naught cell. Means E naught cell is potential difference equal to E cathode minus E anode. That means E right minus E left. It is always at standard condition which can be easily determined. But when you want to determine the E cell at other than or potential difference other than standard condition, then what equation you are going to use? For that purpose, for other than standard condition, for different concentrations, other than 1 molar concentration, you need to use the equation called Nernst equation. So आपको Nernst equation की तब जरूरत पड़ती है जब आप स्टैंडर्ड कंडीशन नहीं यूज करते और आपके कॉन्सेंट्रेशन हमेशा नॉर्मल 1 मोलर नहीं होती. If there is a concentration variation, naturally you have to go, it is obvious you have to go for Nernst equation. It is very simple. It is based upon a mathematical expression and always the numericals are asked from Nernst equation. Let us come on a general reductional reaction. This is your general Mn plus aqueous, means metal who's having an ion, whose ion is removed, whose electron is removed, n number of electrons are removed, written as n plus. It is reduction, so it will receive the electron of n number. N was short, n कम है, तो any electron receive करेगा और उसके बाद metal solid phase में बन जाएगा. It convert to metal which in solid state. Nernst have taken a lot of concept and finally gave us equation which is for electrode, where the metal electrode potential of this metal rod is E Mn plus slash M, because Mn plus slash M is a conversion way of representation of any equation for reduction is for first is its ion followed by its metal, which is written in a slash form, equal to E naught cell under standard condition, and same ion is written again Mn plus slash M. If it was a standard condition, that moment electropotential will become equal to standard electropotential. But it is other than a standard condition. There are some factors start coming there over there, minus, which are responsible for a change of electropotential, minus RT, some constant start affecting. Chemistry deal the parameters which are being solved without derivation of these factors, RT upon NF log base N, metal which is formed upon the ion which was there in the beginning. These are four constants which are decreasing the current flow or which are reducing the electropotential due to this entire factor that compared to standard condition. So we have to remember this part of it. R is a gas constant, T is a temperature in Kelvin scale, N are the number of electrons which are accepted in this process, and F is a Faraday of charge which is flowing into this electrode. Let's come to this. What are the most simple way of representing this equation? The simple way, since in equilibrium as well as in thermodynamics, when the things are taken in a solid form, we take one convention. हम एक convention लेके चलते हैं कि metal, pure liquid, pure solid will be taken as one because its concentration does not vary. Metal का concentration vary नहीं हो सकता, तो आप इसको लिख लीजिए one. Let us rearrange this equation and simplify the equation, the top one into the bottom one. Now rest is as it is. Ln लिखिए, ऊपर metal को 1 लेके चलिए, unity upon metal ion. Most simplification we can do with respect to your Daniell cell or galvanic cell, we can do the derivation of that because this is just the electrode which we are writing it over here. It is only an electrode equation. If this is applied for a Daniell cell or for a galvanic cell, we have to use this basic equation twice and subtract it in order to find out E cell, which is equal to, we have to reframe the equation to finding the EMF of the cell for Daniell cell, where we subtract two equations and we find out in a more simplified manner, that is E cell is equal to E naught cell minus 0.059 upon 2. How did we got 2 number here? Because in this particular equation, loss and gain of electron is of 2 number, therefore it is 2 log product upon reactant ion is mentioned here. Therefore, the equation is mentioned as, by substituting the value of R, T and F, we with all the 3 constant we substitute and one number comes at 0.059. 2 is an electron exchange if this equation has some multiple number. Students, we are proceeding towards some application of the Nernst equation. One of the application Nernst equation to find E cell, that is potential difference between the 2 electrodes. 2 cases we can take. One case where valencies are same. That is just like your Daniell cell or galvanic cell. Second case, in this slide we can see Ni solid slash Ni2 plus aqueous. 2 perpendicular line means salt bridge. Ag plus on the right hand side aqueous and slash Ag. Let us frame this cell representation into equation form. Ni, which is written on the left hand side, means nickel is acting as anode. Nickel is converting to Ni2 plus. आप देख सकते हैं इसकी रिएक्शन 2Ag प्लस के साथ होगी क्योंकि ये कैथोड साइड है. ये इलेक्ट्रॉन को रिसीव करेगा Ag प्लस एंड Ag प्लस कन्वर्ट टू Ag सिल्वर. अब आपको करनी पड़ेगी बैलेंसिंग. Nickel loses 2 electron in this process, but silver plus Ag plus receives only 1 electron. But how come the loss and gain of electron will be equalized in redox reaction? Because every electrochemical cell is a redox reaction. लॉस एंड गेन ऑफ इलेक्ट्रॉन इन हाफ इक्वेशन शुड बी इक्वल। तो आप इसको इक्वालिटी करने के लिए, इलेक्ट्रॉन की इक्वालिटी करने के लिए आप कैथोड रिएक्शन को 2 से मल्टीप्लाई करेंगे। 2Ag प्लस एंड 2Ag आपने मल्टीप्लाई किया तो आपको टोटल रिएक्शन मिलेगी Ni प्लस 2Ag प्लस एरो Ni2 प्लस प्लस 2Ag। Let us write the equation in the form of the Nernst equation as we mentioned earlier. E cell equal to E naught cell after subtracting E cathode minus E anode minus, these are the common factor, RT upon NF. N is 2 here, log base N, Ni2 plus, product concentration upon reactant concentration, Ag plus whole square. Square is a coefficient used in this balanced equation, therefore it is squared. So we have to remember, in a general manner, it is a product concentration upon reactant concentration. If things are taken in standard form, then directly you can substitute as minus 0.059 upon N log product upon reactant. If we involve stoichiometric coefficient, which are those A, B, C, D. अब चेक करिए, इसमें n नंबर ऑफ इलेक्ट्रॉन प्रोसेस में इन्वॉल्व हुए। आपने सेम रिएक्शन को सिंप्लीफाइड फॉर्म में आप लिख रहे हैं, E cell equal to E naught cell minus RT upon NF. Actually, student, this entire factor in equilibrium, product upon reactant concentration, is written as the concentration quotient or Kc. If it is a equilibrium process, we can write as ln Q also in a simplified manner, because integration log base N Q is nothing. It is a product concentration and the reactant concentration other than equilibrium phase. So let us go subsequently. E naught cell minus RT upon NF log base N, C raised to C, D raised to D, A raised to A, and B raised to B. This equation can be used for doing any kind of numerical problem, for calculating E cell or any concentration factor asked in the board examination. It will become easier for you if you learn this equation in this more simplified manner, that is ln Q last. Q means product ionic concentration upon reactant ionic concentration. So we can have another application of equilibrium constant also, another application of presently relation between equilibrium constant and your E cell. This is the second application. First was relation between E cell in terms of calculation of Nernst equation. Second application, relation between E cell and Kc. When the cell is at equilibrium, when cell start producing current, after some time the current stops, because rate of forward reaction become equal to rate of backward reaction. In that case, E cell is equal to 0. You can see, आप देख सकते हैं लेफ्ट में, उस समय कोई करंट का फ्लो नहीं होता क्योंकि पोटेंशियल डिफरेंस 0 हो जाता है। इक्वल टू आपके एक्सप्रेशन में था E नॉट सेल माइनस, आप जब बेस 10 लॉग में कन्वर्ट करते हैं, देन रिएक्शन has this multiplicative number of the Nernst equation 2.303 RT upon NF, that is 2F in case of electrochemical. In case of electrochemical cell, that is galvanic cell, log Zn2 upon Cu2 plus. Let us rearrange this expression to find E naught cell. E naught cell आप left में ले आइए, equal to लिखिए 2.03 RT upon 2F लिखिए, log Zn2 upon CO2 plus. इस इक्वेशन में आप Zn2 upon CO2 को Kc लिख सकते हैं because the equilibrium has been established. जब भी equilibrium established हो जाता है, at that point Qc, that is called reaction quotient, turn equal to equilibrium constant in a particular reaction, which is mentioned earlier. आप इस equation में लिख दीजिए. But you are simplifying this equation in terms of standard condition. This entire factor 2.303 RT upon N will turn into the factor of 0.059 upon 2, where 2 are the number of electrons found in this reaction, log Kc. You will find this electropotential difference. Standard is always equal to 1.1 volt. As we calculated earlier in galvanic cell, it is equal to E cathode minus E anode. The value of subtracting by using electropotential of zinc, that is minus 0.76, and copper is 0.34. अगर आप निकालते हैं E naught cell through that formula, E naught cell is equal to E cathode minus E anode. 0.34 minus, again twice minus comes 0.76, and add it, 1.1 volt will come. Same value is going to come even by this calculation, 1.1 volt. In case you want to find a log Kc, अगर आप log Kc निकालना चाहते हैं, तो log Kc will be equal to, देखिए इधर 1.1 volt into 2 upon 0.059, solve, you will get the value as 37.288. How do we find Kc in this question? To find numerically Kc value, take anti-log of 37.288. When we watch the anti-log, the number which is before the decimal will goes into the power, that is 10 raised to power 37. The number which is after decimal, we will take only one number as 2. We are not taking the remaining one, and take it as, because antilog and log are inverse of each other, we will put that number as 2 into 10 raised to power 37. We will watch, actually we watch 0.28 under 8 place in antilog table. The value will come as 2 into 10 raised to power 37 at 298 Kelvin. So in general, our equation, once again, we are writing the same equation, general equation, other than standard condition, E naught cell is equal to 2.303 RT upon NF log Kc. We should remember it for doing the sums of Kc and E naught cell. Another application of the Nernst equation is to calculate the free energy change in the process of electrochemical cell. Or we can say the relation between free energy and the cell potential. It is again a work which is carried out in electrochemical process. Free energy can be defined as, आपको पता होगा free energy work done है. It is called a maximum work done carried out in any process or any system. In thermodynamically, we write delta G, free energy change, equal to maximum work done in any process or any system. In case of electrochemical cell, it is defined as the amount of charge passed in a cell with the suitable potential difference. How much charge is passed in electrochemical cell according to the potential difference between the two electrodes. Therefore, let us take an equation to find out delta G value. What will be the maximum work done in electrochemical cell by taking an example of galvanic cell, a simple cell using zinc rod and copper rod. Zinc oxidizes to Zn2 plus, copper 2 reduces to copper. Let us write the reaction. For this particular reaction, free energy change will be equal to number of charge required to pass through the electric wire in the particular electrochemical cell with a suitable potential difference. So, two electron give and take is there. Zinc loses 2 electron, copper gains 2 electron. Therefore, the requirement of charge is 2F. The potential difference is E cell. It is other than standard, so we are not writing E naught cell, it is E cell, 2F E cell. When we are multiplying the equation with 2, actually it does not affect mathematically, but it affects in terms of our delta G, because delta G is an extensive property. It depends upon amount of substance. Let us see if you multiply the equation with 2, it becomes 4. NF, we were writing 2 earlier, now we'll write minus. Minus means spontaneous process. The electrochemical cell is a spontaneous process as long as it produces a current. Once it stops producing, then it could become equilibrium, or it may become in a later phase non-spontaneous also. तो अभी तक आपका ये प्रोसेस क्या है, स्पॉन्टेनियस है, तो आप साइन डेल्टा जी का क्या लिखेंगे, माइनस लिखेंगे, 4 से मल्टीप्लाई करेंगे, बिकॉज नाउ इलेक्ट्रॉन लॉस इज 4, zinc loses 2, you have multiplied with 2 the step of the reaction, so 4F E cell. Further things are same. If concentration are taken as unity and conditions are standard, in that case delta G turned out to be standard. We can speak that delta GR, that is reaction under standard condition, equal to N number of electrons, F is a Faraday of charge, and E naught cell is the potential difference between two electrodes. So again, it is a formula for determining free energy, or as well as your E naught cell. Lot of numericals you'll find in your syllabus or in your board exam based upon this formula.